A Nazi cryptography machine based on clockwork routers, it was used to send and decipher encrypted messages written by the Axis military forces, being one of the most important engineering feats of recorded times. This machine still is a subject of many conversations and debate even in today's world full of complex digital encryption protocols. This machine remains one of the most complex encryption protocols to the date. This is an enigma. As impressive as the machine is, a feat of equal importance is that one of the Alan Turing and the Alice Enigma team, which cracked the Axis code and made a significant advance in winning the Second World War. Many men of both sides took the fort lights, hiding the trench and bunkers, using weapons and explosives to try to best their enemies. But behind them were also soldiers who, instead of using guns, fought with their brains and what they knew about mathematics. The Enigma machine was a topic not only of mathematical engineering, but also of history and politics and wartime strategies alike.
Cryptography is the discipline that encrypts and decrypts messages using an algorithm and that also allows the message to be returned to its original state. It's very much in hand with military campaigns and government secrets. Plus, it was very important in World War II, where this became another fighting front.
The Enigma machine was used by the German military command to encrypt strategic messages before and during World War II. In 1930, the codes were broken by the Polish under the leadership of Marin Rejewski, an important mathematician. Then, in 1939, with a high probability of a German invasion, the Polish delivered the code to the British, which created a secret code-breaking group denominated as Ultra. This was possible by the guidance of the mathematician and logician Alan Turing.
The machine was built up by 3 cylinders originally. The cylinders were an elemental part of the system. Each 26 pulsations on the alphabet, the machine changed to the next cylinder and further. Adding another cylinder, the fourth one, made the machine almost impossible to decipher, having a lot of possible alphabet combinations. The basic 3-router Enigma has 26 times 26 times 26 equals to 17,576 possible router states for each of 6 real orders, giving 6 times 17,576 equals to 105,456 machine states. For each of these, the blackboard with 10 pairs of letters connected can be in 150 trillion 738,274,937,250 possible states.
Germany, during World War II, had a huge advantage over other countries because the Enigma code they used was practically indecipherable. This since a fourth cylinder was served to make it more difficult to decrypt the message. Furthermore, the German army changed the code to be used every day, so the Allies had only one day to decipher the message because the next day the code was changed again.
The context for the machine is simple. After the humiliating defeat we suffered after the First World War, I decided to make use of the technological advances of the time to try and improve the communication protocol the German military used so that we could be dominant in the conflict.
making use of the many cryptography materials that the Polish intelligence service recovered. I could create the internal writing of the machine, the part responsible for generating the permutation necessary to script message. This wonderful electromagnetical machine worked by employing in a keyboard with all letters of the alphabet, similar to the typewriter. These keys were some kind of switches that enable the electrical devices and move rotors, which in turn could encrypt entire message.